Now let's find the solution of a half-angle trigonometric equation, and we'll use the half-angle property over here. So we need to prove that this left-hand side of the equation is equal to this right-hand side, and basically we'll take the left-hand side in this case because it's easier to go from a bigger expression to a smaller expression, and the bigger expression is on the left-hand side over here. Okay, and we'll apply the properties on it to eventually turn it into the right-hand side. We have this. So first let's just turn it into its easier, more familiar counterpart. So cosecant theta becomes 1 over sine theta, and cosecant 2 theta becomes 1 over sine 2 theta, and secant theta becomes 1 over cos theta. Very simple. Now let's turn it into a more recognizable form, which is this. Basically, we just have to eliminate this fraction sign. So we replace it with the division sign and then the multiplication sign, after which we take the reciprocal of 1 over cos theta, because when we convert from division to multiplication, we take the reciprocal of the expression that is after it. Okay, and that's just fairly simple math so far. Okay, so we have this. Now what do you do? Well, you'll take the LCM over here to turn the entire expression inside the bracket into one expression, that is without this plus sign. Okay, so once you take the LCM, you get this. And now what do you do? Well, first apply the half angle identity over here. Now we all know that the half angle identity of cos A by 2, right, is equal to under root 1 plus cos A over 2, and the entire of this is in the under root. Okay, and once you need to get this particular term, right? And how do you do that? Well, first you need to take the square of both sides. Okay, so you take square over here and square over here so that you can eliminate this under root sign. Okay, so this square term is eliminated with this under root sign, and so you get cos square A by 2 is equal to 1 plus cos A. But we have only cos theta plus 1 over here, so you take this over 2, by the way, and so you take this 2 to the right hand side, and so 1 plus cos A becomes equal to 2 cos square A by 2. And if you just replace this A over here with theta, you can replace cos theta plus 1 with 2 cos square theta by 2. Okay, and this is the proof. And now what do you do with the denominator? Well, first you cancel out this cos theta and this cos theta. Okay, so you're just left with sine theta, but we need half angles over here, not full angles. So we need theta by 2. So how do you convert sine theta into theta by 2? Well, you know the double angle identity that says that sine 2a is equal to 2 sine A cos A, right? So the multiple is over here. And so you can also write basically sine A is equal to 2 sine A by 2 cos A by 2, right? Because these are the angles and the double of the angle is over here. So these are the angles A by 2, and the double of A by 2 is A. So you apply the same property on sine theta. So sine theta becomes 2 sine theta by 2 cos theta by 2, like sine alpha was equal to 2 sine alpha by 2 cos alpha by 2. And so you get this. And now you can just cancel out this this cos theta with 1 of the cos theta in the denominator, in the numerator. So you're left with, and you can also cancel out this 2, by the way. So you're just left with cos theta by 2 over sine theta by 2. And that just becomes cotangent theta by 2, and that was equal to the right hand side. And so we've proven that the left hand side is equal to the right hand side.